This is question 1 from the warm-up. The first one said, find the minors and cofactors of the matrix. So the 2 by 2, you're literally just crossing through the rows and columns in each spot. And then you end up with 6, 0, negative 5, 2. And then for the cofactors, remember the first one stays, second one changes sign, third one changes sign, fourth one stays. So the 0 obviously doesn't carry a sign, otherwise that would be opposite. And then the negative 5 becomes positive 5. Overall, most people did good on that one. I think there was like maybe 1 or 2 mistakes. The second one of the minors and cofactors, you're crossing through the row and column of each one and then finding the determinant of what's left. So you should have gotten 3, negative 4, 1, 2, 2, negative 4, 10, and 8 for the minors. And then for the cofactors, remember it's the north, south, east, west locations that you change the signs on. So based on that, I would keep the positive 3. I would change the negative 4 to positive 4. Keep the 1. Change the 2 to negative 2. Keep the 2. Change the negative 4 to 4. Keep the negative 4. Change the 10 to negative. And then keep the 8. So the cofactors should have looked like that. Again, overall good. Some of you were still working when I went in there, but overall good. The third one was the determinant. I think everybody got this one, so good job. This is just the fish, right? Negative 2 times 4 minus the negative 1 times 3. The minus the negative changes, and I get negative 5. Questions before we move into the 3 by 3? Okay, so yesterday we started 7-7. We did the determinant of the 2 by 2. We did the minors, and then we did the cofactor. Today we're going to do the determinant of a 3 by 3. I said it yesterday, but I'm just going to repeat it, that there is 2 ways to do this, and the notes actually show you the other way that I don't even, like I used to teach both, and nobody picks this method, so I'm not even going to waste the time, okay? So this is, if you did want to learn this method, this is why you need to know the cofactors, really. It's called expanding it, and you expand it by either a row or a column. you would take the cofactors and you would multiply in by what's left after you remove that row and column into determinants, okay? And so the cofactors are this pattern, this plus minus plus pattern. That's where that comes from. We are not going to do this. We are going to skip this. We are going to go straight to the example, and I'm going to show you how to do it. So the way to do a 3 by 3, or one way to do a 3 by 3, is you take the original matrix that's there, and you rewrite columns 1 and 2 to the right of the last one. So I duplicate columns 1 and 2. So it'd be -2, 1, 3, that's column 1. And then I duplicate column 2, 1, -1, 1. Just columns 1 and 2. Then I draw diagonals, and the first time I draw them, I go from top left to bottom right, that same diagonal we start with when we do the fish. So here, here, and here. You should get 3 full diagonals with 3 numbers. That's why we duplicated the columns. And I multiply each of these diagonals. So -2 times -1 is +2. So I do -2 times -1 times 0. -2 times 1, or -2 times -1 is 2 times 0, and this is 0. Then I multiply down the next one. So 1 times -2 times 3. So I get -2 times 3, which is -6. And then I multiply down the next one. 0, 1, 1, and that's 0. So I'm multiplying down the diagonal. And then I add these 3 numbers together. 0 plus -6 plus 0 is -6. I'm going to use that in a minute.
This will always work.
Always.
So you don't have to do the other.
So I'm not even going to teach it to you.
What?
The minors and cofactors way. Like the minors and cofactors, you have a question on that. But the way of expanding using those, I'm not even going to teach you.
No, but like the minors and is this going to give us the same answer that
Yeah.
we just did in the warm-up?
No, that was minors and cofactors. We didn't do a 3 by 3 determinant.
Okay.
Yeah, different question.
Okay.
Yep. Okay, then I'm going to go the other direction. Diagonals going back the other way. So if the order is important, I have to do the top right, bottom left ones first because I'm going to then subtract these. So the order is important. It goes the same order as your fish. All right, so I am multiplying down these diagonals. So 3 times -1 times 0, which is 0.
What do you mean it goes in order?
Like we start the fish here, right? We do that diagonal first, and then we come back and do that diagonal.
It doesn't matter if you multiply from top to bottom.
No, that doesn't matter. You just have to do all of these, add those, and then you do all of these because we're going to take the first thing and subtract the second from it. Then I'm multiplying down the next diagonal, so -2 times -2 times 1, which is 4. And then I multiply down the next diagonal, 0, 1, 1, which is 0. I add these together, and I get 4. And then I have to do the first number I got. This is why the order is important. So this would be -6 minus the second number I got, and that's your determinant. So it's like a big giant fish because you have to do it 3 diagonals. Huh? Yep, that's the determinant of that matrix. All right, so same set of instructions. First, it says evaluate the determinant by hand and then check your answer in your calculator. So we start by duplicating the first 2 columns. So -2, 3, -1, 1, 0, 2. Obviously, a super important step to do carefully because if you lost that negative, now everything involving that negative is wrong. Then I'm going to multiply down, top left, bottom right first. So -2 times 0 times 3, which is 0.
You just skipped the first 2
1 times -1, which is -1. And 3 times 2, which is 18. And then I go back the other way. Three times 0 times -1, which is 0. -2 times 1 times 2, -4. and 3 times 3 times 1, which is 9. Oh, I didn't add these, but I'm going to add these together. I get positive 17. Add these together, and I get positive 5. And then I have to do 17 minus 5.